back, everyone. We are continuing our investigation into linear relationships. Mr. Ford, how are you doing today?
I'm doing great today. Beautiful day.
Awesome. So
no technology hiccups so far.
Oh yeah, no technical difficulty whatsoever. All right, so today we are playing the role of some inspectors or engineers at the line factory. And so in this problem, we're going to pretend that we have a bunch of customers placing orders for lines, and our job, and yours, is to, if possible, once you receive their order, and then give them a graph and equation of the exact line that they're asking for, if possible. Sometimes their order might not be specific enough though, and if that's the case, we're gonna have to give them options as to what their line's gonna look like because they weren't specific enough. So, Mr. Ford, do you want to take us on to this first one here?
Absolutely.
Line A goes through the point 2,5.
Sounds good. Okay, so we have a line A. We have an order out here for a line A. It's going through the point 2,5. So it looks like I have my x coordinate here at 2. So if this is 10 right here, I'm just going to kind of sketch this. All these are just kind of sketches. If you notice here, it says that you got to standardize your graphs by scaling the axes from -10 to 10, -10 to 10. So we try to do that on all axes here. So let's just see here. Yeah, let's just see here if I can kind of locate where 2,5 is. So it looks like we're going by a little over 3s here. So this might be around 2. And then 5 is halfway between 0 and 10. So maybe around here would be 5. So I know that a point would be on this line right here. And I said this line because we need a singular line, right?
Yeah.
I mean, like exactly one line that goes through the point 2,5. That's what's been ordered, a line A. Well,
yeah, that's what they asked for.
Yeah, I mean, I can send this customer a line. You know, I can get them a line. I can get it to them by Friday, right? I can send it out, ship it, 2-day shipping, Amazon Prime it to them. I can get them that line, but I don't know if it's the exact line they're looking for because they had one and only one line that they were thinking of. So anyways, I mean, I could draw this line. I can get this line to them. You know, in fact, I could overnight to them and get it to them by Wednesday. And
I think that would satisfy their order.
That would satisfy their order. But I think here it said that we needed to produce one and only one line. So, you know, if they just told me this, I could send them that, and then they couldn't return it to me because, you know, that they didn't give me enough information, because it turns out that they could have wanted a different line. Could have potentially have wanted this line right here. That line also goes through this point right here, right? It also goes through 2,5. Yeah. So, you know, I think I want to be nice here. You know, I want to reflect well upon the line factory. In fact, you know, I could have sent them a vertical line, right, at x equals 2 here. That goes through 2,5 as well. But, you know, we're respectable people. We want to do well for the line factory because there'll be more problems involving the line factory too. We don't want to ruin all of our customer relationships. So I think I'm going to tell them that this was not enough information for a specific line. No, not enough information for a specific line. Yeah. So I don't think we need to come up with an equation for that one. And that's
it. Yeah, because there'd be too many equations to create. They don't pay us enough for that.
Exactly. So we were given there. What were we given in this problem? We were given what?
So in this one, for this order, we were only given that the line has to pass through that 1 point.
Yeah.
2,5.
Okay. So we were just given 1 point, and through 1 point, that's not enough information to draw one and only one specific line. So not good. Not good. Okay?
Definitely agree.
All right. Anyways, I'm going to kick it over to you, my associate here at the line factory. Let's see if you can produce. I got another order from a person who wants a line B. That has a slope of -3 and goes through the origin. Let's see here if that's going to be enough to go through.
Yeah, so let's see. I know past the origin, I like to start off with the point when I'm drawing the line.
Okay, so we're given a point. I'm going to just write that down here while you're talking.
Oh, yeah, let's write that.
What are you given? We're given a point. Okay, where's the point?
And we also have the slope.
Oh, we're also the slope. Okay, cool. Point and slope. Nice.
That's fine. So again, we plot down the origin there. So that's right where our axes cross at 0, 0. And let's see, since we know the slope now, we actually know exactly how slanted or how steep our line is. So let's see, a slope of -3. So if we talked about slope being rise over run, so that would mean I rise -3.
Okay, so I'm going to go down -1, 2, 3.
And then we're going to run to the right. Just 1.
Okay, let's do an actual formal slope triangle, I think, right here. So let's go down 3, and then we'll go over 1. Okay, so down 3. This is down 3 because it's negative, and then we'll go +1 this direction. and then I'm going to add another point on that line.
I could draw another one if I wanted to, right?
Yeah.
Another down 3 and over 1.
Yeah, let's try another one.
Another down 3 over 1, and so on. But I think we don't really have to, because if we know that the slope is the same every single time, then we already know that that's going to create that straight line.
Okay, cool. So that straight line being the line going through these points here that would be connected through that -3 over 1 slope. So I'll go ahead and draw in a sketch of that line.
That's
and this is our draft. I don't know if I'd mail this to a customer right away, because we probably want to use a ruler and a really good graph. But I think that's good enough to at least know that we can generate a specific line.
And I don't think there's any wiggle room for like moving the point, because it has to go through the origin.
Yeah, exactly.
Like the first one has to go
it's fixed to the origin. Yeah.
But in the first one, they didn't tell us how steep or what the slope is of this line.
I like the way you put that, because it's like location, and then how does it grow? Like if we have one location and we know how it grows, then we're good. So it doesn't even have to necessarily be a y-intercept, for instance. It's nice that the origin is a y-intercept, but as long as we're fixed in one location and then we have a growth rate for a linear function, we're good to go with getting a line. Okay, I like that. Cool. Do you want to try the equation there? So
we know our equation is mx plus b, so we know m, or our slope. Luckily, it was given to us in this one, so it's -3.
Nice.
Times x, or -3x. And our y-intercept, or our figure 0, it looks like it would just be at the origin.
Yeah. So that's our b right there. So that's our y-intercept. So b equals 0.
Yeah.
Okay. So I guess I could put +0 here, but I don't even need to put +0.
Yeah.
It's probably doing too much work here. So I'll just go and box this.
Or just -3x.
Yeah, I'll just box this and cross that out. Cool. Very good. All right, cool. Let's see if C has the opportunity to give us a specific line right here. What are we given here? Let's actually, I like starting with what we're given, and then we can decide if that's enough. So we're given 2 points right here. Okay, so let's go ahead and write that down. 2 points. So -3, -2 is 1 point. And so 2 points. And so here we're given 2 locations, right? A point's just a coordinates on the graph, right? 2 locations. So if I have a point here, again, let's say this is -3. Okay, if that's 10, this is probably around where -3 is. And then -2 is going to be right around here. So let's put -2. So it looks like I have one of my points. Let's do our graph in red and see if that works out. Here is -3 and -2. And then, yeah, awesome. And then my other point is going to be, they're both positive here. Okay, so we're in the first quadrant.
This one.
Yeah, 3. And it looks like it's going to be going up, because I got to go from 3 up here to get my other point. So 10, and here is 10 right here. Already conveniently placed on our graph, but we got our other point right here. We'll do this in red. Okay, so 2 points here. We have a saying for 2 points. We teach geometry too. I don't know if you guys know that, Mr. Cheng and I. Do we ever teach geometry? But through 2 points, Mr. Cheng, exactly
1.
Exactly one what?
Exactly one line passes through both of them.
Exactly one line passes through 2 points. Okay, so very good. So this one here, you should probably notice that pretty easily, that if you have 2 points, you're only getting one line there. Only getting one line there. So 2 locations. So 2 locations, I like the idea of sticking with I have the origin and I have the growth. That's enough. So I like the idea of talking about location and growth being enough here. If you have 2 locations, that's going to tell you the growth here, which is kind of like one of the big parts of this lesson. After you guys do 237, 238 is going to talk a lot about just if you have 2 points, how do you get the growth pretty quickly? So let's see here if we can talk through maybe just using in the graph how we would figure out what the growth is. What do you think we should do, Mr. Cheng?
I think we can see, let's see, to get our growth, there's always 2 pieces, the rise and the run, right? So why don't we figure out the 2 pieces separately?
Okay, cool.
So let's see, we know we're rising by starting off. Let's read it.
Yeah, we're definitely rising because it's an increasing graph. Yeah.
So let's see, our altitude, or our height for that first point is at -2.
Okay, -2.
And then we end up, and we're rising up to +10.
Okay.
And so the question is really just, Well, how far away is -2 to 10?
To 10, yeah. Well, -2, I know -2 is 2 away from the x-axis, and 10 is 10 above the x-axis. So this here's got to be +12.
Yeah, the total difference in that height is going to be 12 for sure.
Yeah, right. So reasoning through it. So notice here, like these are just sketches we're doing, which is fine. Hopefully you're doing sketches too. Save yourself the work. Don't have to count up all the spaces, right? It's okay if you're doing that too in your own graph paper. But yeah, if this is 10 above and then this is 2 below, then looking like this is +12. All right, so I got +12. That's part of my slope. What are you getting for this here? So now I'm going to draw over the run. Yeah, my rise going to run.
Similarly, going from now the x's, we from -3 to 3. That's going to be a difference of 6, and we can kind of see. It's nice that it mirrors on this case. In this case,
yeah,
because you're 3 away from 0 on the left side and 3 away from 0 on the right side as well.
Yeah, this is +3 right here, and then this is another +3 right here.
Yeah.
Okay, nice. This helps us thinking about maybe simplifying this slope a little bit here. So maybe I'll write down a little bit about the different ways we can write what the slope is, because we're going to need that for the equation. And slope, you mentioned earlier, slope is rise over run. So we can do rise was 12 and run is 6. So this is a perfectly acceptable slope, but I think we can simplify that. We might as well simplify that if we're putting that in our equation. So that simplifies to 2. Right, yeah. 2, exactly. Okay, cool. Nice. Okay, so that's going to help us get started with an equation. This is kind of one of the harder ones on here, I think. So yes, this was enough for a specific line.
Yeah.
And the equation,
I don't think there's any wiggle room to get between those 2 points. Like once you lock them in with 2.
Right. Growth is set with a line at least, right? Because a line's growth is constant, right? It's consistent. So we know we can just put that growth directly into the equation. So 2x. And then the hard thing, right? So we do have 2 of the locations, right? 2 of the locations of this line, of this linear function here. But these 2 locations here, they're going to help us get the equation of the line later. You'll have the skills to kind of figure out the equation line a little bit quickly. So hold that thought for a second. But what's the big location of this line that we need to know in order to get the equation now? Because we have this point, we have that point, but these aren't the 2 most important points for now. We need to get the
y-intercept starting value.
Yeah. So we need to figure out what this is here. So what do we think? So this is, I think I'm going to connect to what you said a couple minutes ago, Mr. Cheng. You said that this was 3 away. Right,
yeah,
3 away. Yeah, the y-axis is 3 away this way, and it's also 3 away this way here. So if we have to think about it, 3 of it. So I might be doing too much right here, but remind you that the slope here is 2 over 1, right? Our rise, so if our rise is 12, run is 6, then an equivalent slope, right? An equivalent slope, the unit rate here is rise 2, run 1. So if I had to run 3, it looks like I'm trying to run 3 right here. Question is, if I'm running 3, what would my rise have to be? And my rise is going to have to be 2 times that, right? So it's going to have to be 6. Okay, so that should put my y-intercept where? So we got -2. So
we add 6 up.
Yeah, add 6 up. So if we add 3 here, that would bring us to 0. So this would be 0. The y-intercept would be at 0, comma, and then we have -2. Add 6 up. That'll bring us to 4.
Yeah, 4.
And that gives us the y-intercept +4. All right, I feel good about that one. I think you guys, next question, we'll have a faster way to do that. So I look forward to that, but hopefully you got what we got here. All right, part D. Want to give that one a shot, Mr. Cheng?
Yeah. This one's interesting because it gives us a table. So unfortunately, it's not as nice as it could have been. It doesn't give us when x equals 0. We're starting us off at when x equals 2 and y equals 1. And we have a couple other points at x equals 3, 4, and 5.
Do you think we should plot some of these points, maybe?
Yeah, probably some of them.
Okay, let's do it.
I think, actually, while you're doing that, I think I noticed that this is actually very similar to C, that we just did. Like, it didn't explicitly say, like, goes through this point and this point, but it essentially did say that, it gave us a table instead.
True. It's giving us a little more information. We have more than 2
points.
Give us but 2 points is really all we need, right? Through 2 points, exactly one line can be drawn.
I guess it doesn't hurt, though, to still maybe plot them just to make sure that it actually is a line.
Yeah. Oh, good idea. Good thinking. 3.5, 3.
I think we could also see that on the table.
3.5.
If we check the growth, right? So let's see. Each time in the table that they give us, all these points, their growth in x is +1, +1, +1. Yeah, a run of 1. And then the rise between each point, let's see, from 1 to 3.5, that's going to be a rise of, I think, 2.5.
So in the table here, unfortunately, I can't draw on the table here, but in the table, every change in x equals 1, right? 2 to 3. And then the change in y was what? 1.5.
I think it's 2.5.
Yeah.
Yeah. If I just double check my calculator here, let's see, from 3.5 to 6, I think it's also 2.5.
Mm-hmm.
And same thing from 6 to 8.5. Yeah, so that growth is actually the same all the way through. So this thing has to be a line as well.
Yeah, it has to be a line as well. And I would agree with this, that here, this is a line. And let's get the slope right now, because I think there's only one line. I think the easy part we can put in is that this is only enough for, like, if we had 2 points.
Oh, yeah.
And we knew it was a line. Yeah, then that would be enough to draw on a specific line. If we have more than that, right, this is definitely a line. But I think the big thing we got here was the slope here, which was 2.5.
Yeah, you get so easily out of that table.
Yeah, easily out of the table. And just looking at the points here, I think the slope makes sense, because if you look at the points and where this line's going to be, I'm going to sketch it in just to have it here. But the slope of 2.5 really makes sense to me, because this line's pretty steep. Right? It's a pretty steep line. Not an incredibly steep line, but it's not really that flat. Right, it's going a little steep here, and so the slope is bigger than 1, right? The slope of 2, that's a pretty steep slope. You get bigger. The bigger your slope is, the faster the growth. And this is pretty fast growth right here. So I think we're in good shape here. Yeah. So it looks like we have a negative y-intercept. Yeah.
Yeah, so I like how we could do a similar thing to what Mr. Forden did in the previous problem, except now we're going to have to go backwards, because we don't know anything earlier than x equals 2. But if we start off at x equals 2, we're going to have to take 2 steps backwards to get back to x equals 0. And so if we're running backwards 2, then our rise, we're going to have to fall 2.5 instead of rising 2.5.
Yeah, I might just sketch the table over here for a second, just because we had the 2. So I think what you're trying to say, unfortunately, I wish we could write on it, but it is what it is here with these technology issues. Yeah. But if we're going, if we're going 2.5 this way, right, and plus 1 this way, then what you're saying is here we can go back by
minus 1,
and then
the y be minus 2.5.
And this would be representing a slope of positive 2.5, right? Because if your delta y were negative 2.5, and then your delta x is negative 1, right? Yeah. The negatives would cancel out. So negative 2.5 or negative 1 is positive 2.5. Okay, cool. I like it. So let's fill it in here.
So right there, that'll be negative 1.5.
And then, wait, no, is this negative 1.5? No, it is. You're right. Yeah, because it's 1 minus 2.5. Yes.
And we do that one more time, then we'll get down to negative 4.
Negative 4. Okay. And I'll buy that. Yeah, it looks like this would be around negative 4. If that's negative 10 down here, it's like a little bit closer to the x-axis than negative 10. So looks reasonable to me. It looks like it makes sense. Nice, cool. Getting equations in this lesson here.
Wait, minus 4.
Oh, minus 4. Yes, good call. So done pretty well. Got 4 equations, and you guys could probably do the rest, I think. Line E is pretty close here. So some of these are pretty quick, like line E is one where we didn't really have. So I guess this one here, sorry, we didn't summarize part D here, what we were given. But what were we given? We were given more than 2 points. Yeah, we were given more than 2 points. So I might just put down 2 points, or at least 2 points is enough to kind of generate the equation of a line. If it is a line, right? That's another thing you need to double check here. So like line C, it says line C goes through points -3, -2, and 3, 10. Because they said it's a line, you can generate a line from that. So be careful on that for some of these other ones here. So you're basically given 2 points here in a table, and that was enough. And you knew it was a line, so you were fine there. Point and a slope was enough to create a unique line, but 1 point wasn't enough to create a unique line. So so part E here, you're not given a specific point, right? You're not given 1 point, but you're given 1 slope. So maybe I'll just write that down, and maybe you guys can do it on your own in a second. But is 1 slope by itself enough to draw a line? What do you think, Mr. Chang?
Well, I think, let's see, we could just draw one, right?
Yeah, let's just draw one here. Okay, so let's just maybe draw one that goes through like a y-intercept of 2, for instance. Then we'd have to do grows, rises 4, so up here to 6 or so, right? Plus 4. And then runs 1. So this is kind of hard to see here on this graph, but
it would be super steep, even more steep than the first.
Totally. Something like this as a sketch.
Yeah.
I think we can draw another one, right?
Yeah, because this one, she didn't ask for a y-intercept of 2.
Yeah.
Maybe they asked for a y-intercept of, I don't know, negative 3 or something.
Yeah, totally.
So,
So we don't know what
that
that customer
line.
wants.
As long as it's the same slope, same steepness, it still satisfies the order.
Yep. So -3, I'd have to go up to +1 here. And I guess something interesting happens here. A little vocabulary word happens here, that these lines have the same steepness, so they're going to have the same slope if we go over +1 here. And because of that, it looks like these lines won't touch at all. Growth rate of 4. Constant growth started in different places. They don't touch at all. Got a little messy here. Try to highlight a little bit, but yeah, they don't touch at all. So enough for one specific line? Nope.
I think so.
Nada. So we don't need to worry about an equation for that specific line. All right, very good. Cool. You guys can do these next ones later. We'll share the answers to F and G, I guess, at the end of the video. So pause the video now and attempt parts F and G. We'll do them too right now, and you can check your answers afterwards. Good luck, guys.
I am not throwing away my shot. I am not throwing away my shot. Hey, yo, I'm just like my country. I'm young, scrappy, and hungry, and I'm not throwing away my shot. I'ma get a scholarship to King's College. I probably shouldn't brag, but dag, I'm amazed and astonished. The problem is I got a lot of brains, but no polish. I gotta holler just to be heard with every word. I drop knowledge. I'm a diamond in the rough, a shining piece of coal, trying to reach my goal. My power of speech, unimpeachable. Only 19, but my mind is older. These New York City streets get colder. I shoulder every burden, every disadvantage I've learned to manage. I don't have a gun to brandish. I walk these streets famished. The plan is to fan this spark into a flame. But damn, it's getting dark, so let me spell out the name. I am the ALEXANDER. We are meant to be a colony that runs independently. Meanwhile, Britain keeps on us endlessly. Essentially, they tax us relentlessly. Then King George turns around, runs a spending spree. He ain't never gonna set his descendants free. So there will be a revolution in this century. Enter me,
he says in parentheses.
Don't be shocked when your history book mentions me. I will lay down my life if it sets us free. Eventually,
So we just want to leave you guys with a little summary of what we've done today by building these connections between our pieces of our algebra web. So we took the notes from problem D that we did earlier, and we broke it down to its different representations. So here's the table that we had filled in for that problem, and then there's the graph alongside it, the equation we ended up with in the bottom right corner, and then we also wrote up a little story that would also kind of represent this. And so we kind of want to build the connections and see where do we see the different pieces of the equation in the different representations. And I think that it's pretty clear to see where that B component of the mx plus b comes in. If we look at our equation, our B is -4. So I know it says -4, but you can always think of subtraction as saying plus -4. All right. And so in the table is actually really handy. So I know we didn't have this at the beginning, but assuming that this data actually is a line, you should be able to work backwards or forward, depending on where you are, to actually find that y-intercept. And then that y-intercept, of course, happens when x equals 0. And so, yeah, in this case, we started off where our earliest x value was 2, so we have to take 2 steps backwards to get to that -4 for our y-intercept. And Mr. Foreign drawing that in for us right now. And so that's where you can see it on the table. In the graph, it's nice because, again, our starting value, aka figure 0, aka y-intercept, well, that's just where our line crosses our y-axis. Again, that vertical axis. And so this one maybe is not always the clearest, depending on how accurate or how messy your graph is. But assuming you did it correctly, you will be able to see it right there. And then in our situation here, again, starting value for our y-intercept, or figure 0. And so Mr. Lee, in our story, starts his race 4 meters behind. So Mr. Lee's a pretty fast guy, so he's handicapping himself in this scenario to give everyone else a chance. But yeah, he's starting 4 meters behind. And so that's where that starting value, that's where we see our y-intercept. And Mr. Foreign, do you want to explain to us how we can see our slope, our growth rate?
Absolutely.
In our scenarios? representations?
Absolutely. And again, because we already did this one in part D, and it was just a great candidate to use this one for your learning log here, we already had our equation built, so we can use that to point out our growth here. And that's obviously our other number that appears in the equation, our other parameter here. So our M parameter, M equals 2.5, and that's our growth, which we could maybe summarize at the end. And then, right, because we'd already done D, we had the equation, that was nice. D was the one that actually we started with the table, and I think it's pretty easy in a table usually to see it because you look to the outside of your table to figure out what the growth is. So it might be a little confusing in this one because we are working backwards, but if we did, our change in Y was negative 2.5 and our change in X was negative 1, that would get us to the same slope of negative 2.5 over, right, delta Y is negative 2.5, delta X is negative 1, negative 2.5 over negative 1 would actually simplify to 2.5 over 1, or just 2.5. So we can get it from outside the table, but it might be a little bit nicer if you just kind of work forward, right? Usually you get the slope this way. You can do, and it's nice to have, these are called consecutive numbers, right? The consecutive integers, which are just whole numbers, right? Positive, negative, could be positive, negative, whole numbers that are just increasing by 1, right? This number plus 1 is 3. So we had a delta X of plus 1 right here, and its corresponding delta Y is plus 2.5. And you can always get that plus 2.5 or the delta Y by subtracting backwards, right? So starting with the later Y value and subtracting the earlier Y value. So 3.5 minus 1 is 2.5. And so here's where you get that. M is 2.5, so you can take these two together, right? This is our slope here, 2.5 over 1, and that simplifies to 2.5. Right here for M. And then on the table here, again, the same thing that Mr. Cheng said, okay, depending on how messy your table is, how messy your graph is, it can be harder to spot the slope than in maybe some other representations. But if you have the coordinates actually marked, it's a little bit easier. And if you've done problems 238 and 239, you might have some tricks here now. And I hope you do have those tricks here now for when you do have two coordinates like this, 0, negative 4, and the other coordinate that's I put here, right? So I chose this coordinate and I chose this coordinate to help me graph this out down here. The other coordinate I have is 2, 1. So you should have some shortcuts now where you don't even need a graph with those two coordinates to figure out what the slope is. But if you did have a graph, you would know that your rise, right? Rise over run. So our rise here is going to be how our Y's are changing. So we're going from negative 4 and we're going up by, it looks like, did I do this correctly? Negative 4, yeah. Yeah, we're going up by 5. Yeah. Okay, so it might not appear to be a decimal right now, but the only reason why this is plus 5 right here is because my Y's increased by 5, but my X's look like they increased by 2. So both Y's and both X's increased. We got a positive slope, which is nice. But here, my M, according to those 2 points that I used, was 5 over 2, okay, which also it simplifies to 2.5, right? 5 divided 2 ways means 2.5 for a slope. And in my equation, I see that because I'm going to use what Mr. Chan said on another video because I liked it, but also talk about the graph a little bit here. The slope here is my change number, and my change number I can spot by seeing words like every or each or per. But per, something, per, right? Per is a good one. So we see per, right, usually has to do with the change number. And what I'm going to start saying is what Mr. Chan said in another video is your slope number is the one that actually talks about both of your variables too. So this slope number here involves both of these numbers here because both variables are getting talked about. So 5 meters per every 2 seconds. So here I got my Y value talked about because meters is my Y value. And seconds is my X value in this situation, my X variable, input variable. So that's just a little bit of a trick there for finding your slope is per, each, every, right, stuff to look for. And then also if they're talking about more than one variable for that slope number, if it's 2 numbers here kind of included together, it's probably your growth number. So 5 over 2, and then again, we simplify unit rate to 2.5. And that's it for the learning log. All right. Thanks, guys. Thank you, Mr. Cheng, for joining us here. This was
no problem. See you all next time.
We'll do this again soon. Bye, guys.